Chinese engineers just bypassed 50 years of Western microchip physics by literally folding their logic circuits in half, skyrocketing transistor density without touching a single restricted American machine. By making traditional manufacturing impossible, Washington inadvertently handed Beijing a clean slate to completely reinvent modern processing power. Meanwhile, the American tech sector has disintegrated into a bloated, VC-funded burn pit entirely detached from physical hardware realities. This isn't an AI golden age, it is the hubris of a legacy empire steering straight into an iceberg. And if you want undeniable proof of how spectacular this containment strategy collapsed, just look at Nvidia's public, humiliating reality check in May of 2026. Nvidia tried to play the game. They engineered the RTX 5090D V2, built on the advanced Blackwell architecture, and they deliberately nerfed it. They cut the memory down from 32GB to 24GB of GDDR7. They choked the memory bus to 384-bit, they throttled the bandwidth and the tensor core performance just to squeeze under the US Commerce Department's threshold. Officially they said, hey, this is explicitly for Chinese gamers and 3D animators. But guess what? Chinese AI devs, they starved for unrestricted H100s and H200s and the full fat Blackwells. And they started using the 5090D V2 as a massive backdoor. Enterprise firms were retrofitting these custom cards, doubling the VRAM to 48GB, and racking them at scale for generative AI workloads. So Washington panics, of course. They start deliberating on tightening restrictions again, but the definitive crushing blow didn't come from Washington, it came from Beijing. On Friday, May 15th, 2026, Chinese customs officially added the RTX 5090D V2 to a list of banned import goods. They explicitly told logistics companies, we no longer process import permits for this American hardware. And the timing? Absolute fucking poetry. The ban was enacted during a high-profile state visit to Beijing by President Donald Trump, and who was with him? Nvidia CEO Jensen Huang. Jensen literally got a personal phone call mid-journey and was pulled onto Air Force One in Alaska just for this trip. The whole point was to negotiate bilateral AI guardrails and get operational approvals for Chinese hyperscalers to actually buy Nvidia H200 chips. Instead of capitulation, Beijing looked at the American delegation dead in the eye and sent an unequivocal signal. We no longer want America's downgraded hardware scraps. The US Commerce Department technically cleared licenses for 10 Chinese tech firms like Alibaba and Tencent to buy 75,000 H200 chips each, but they attached draconian stipulations. Remit 25% of the revenue through US territory, mandatory third-party lab verification, strict military non-use certifications, and yeah, right, who's gonna fucking care? Beijing actively responded by attacking those undisclosed domestic conditions that made those US licenses completely unworkable. The result? 0 actual chip deliveries. Let me repeat that. 0. By officially banning the 5090 V2 and intentionally stalling H200 imports, China purposely cut off its own back channels to Western compute. American sanctions didn't ultimately sever the umbilical cord to Silicon Valley. China severed it, reacting to the indignity of those sanctions and forcing its domestic sector to rely entirely on homegrown alternatives. So yeah, the strategic fallout from May 2026 exposes the core flaw in the American approach. We thought we could starve them by restricting high-end semiconductor manufacturing tools, specifically ASML's extreme ultraviolet or EUV lithography machines. But we executed this strategy with the chaotic reactive nature of a Little League game where the umpire randomly alters the rules every single inning. This unpredictable regulatory environment introduced absolute panic in American hardware execs. Look at AMD CEO Lisa Su flying out to Shanghai to negotiate upper mid-tier AI chip sales, desperately trying to pressure revenue in a market that historically made up a quarter of AMD's global sales. We intended to permanently freeze Chinese manufacturing at the 7nm node. Instead, we triggered a massive architectural pivot. Because Chinese engineers couldn't shrink transistor sizes horizontally, what we call geometric scaling, they didn't just give up, they rethought chip design entirely. Western semiconductor manufacturing currently suffers from an IPv4 problem. We are dragging around 50 years of accumulated planar two-dimensional architectural legacy. It's highly capital intensive to shift away from it, and it disrupts our established supply chains. By forcing China to start from square one in the 2020s without EUV access, the US inadvertently handed them a clean slate. And at the 2026 ISCA Symposium in Shanghai, Huawei semiconductor president Ha Tingbo showed us exactly what they built on that slate: the Tau scaling law and logic folding. Traditional Moore's law dictated that you increase performance by physically shrinking the transistor gate length. But the Tau scaling law, it entirely shifts the optimization target away from the transistor itself and onto the single propagation delay between transistors. Because in modern processors, the time it takes for an electron signal to travel across the wiring is what dominates total latency. To aggressively compress that signal delay, Huawei developed logic folding. Instead of routing metal connections across a flat 2D plane, they redistribute combinational logic verticality across multiple active layers. They utilize precise through-silicon vias and enforce a strict hybrid bonding pitch of less than 2 micrometers. By stacking circuits vertically, the physical path length of electrical signals drops sharply. RC delay is mitigated, clock skew is massively reduced. The commercial manifestation of this is the Kirin 2026 smartphone SoC. By expanding from a single layer to a double layer active architecture, they bypass traditional node shrinking entirely. While geometric scaling over the last 3 years barely moved density from 126 million transistors per square millimeter to 155, the introduction of logic folding skyrocketed the density to 238 million transistors per square millimeter in a single generation. Alongside a 41% improvement in energy efficiency and a peak clock frequency of 3.1 GHz. And they aren't stopping at consumer electronics. They plan to apply system folding across their entire hardware stack, including Ascend AI processors, by 2030. They are bypassing protocol conversions entirely with unified bus tech, dropping data latency from microseconds to approximately 100 nanoseconds. They rolled out the High-1 optical interconnect engine, providing 8 terabytes a second of bandwidth, effectively making disconnected server chips behave like a single chip. Huawei confidently projects by 2031, this methodology will achieve density equivalent to a 1.4 nanometer process technology, entirely without restricted Western EUV equipment. While TSMC execs are out here defending traditional transistor scaling, the fundamental reality is that US sanctions did not kill Chinese tech. We vaccinated it against Western reliance. By making traditional Moore's law physically impossible for them, Washington inadvertently accelerated China's global transition to 3D post-Dennard scaling architectures. So while China leverages physical manufacturing constraints to force architectural breakthroughs, the American tech sector has increasingly transformed into a financial burn pit. Silicon Valley is currently operating on the absurd, mathematical, unsustainable economics of an AI bubble. Companies are seeking trillion-dollar IPO valuations based heavily on VC hype and the theoretical promise of AGI, completely divorced from actual near-term profitability. It is an absolute disaster waiting to happen. Look at Uber in early 2026. They deployed agentic AI coding tools, Anthropic's Claude Code and Cursor, to their engineering teams. Guess how long it took for Uber to burn through their entire allocated annual AI coding budgets? 4 fucking months. This wasn't reckless spending, it was simply the unenforced exponential velocity of adoption. Roughly 95% of their 5,000 engineers were actively using the tools, generating about 10% of this total submitted code base. Because generative AI runs on usage-based token economics, it transformed software from a predictable SaaS expense into a wildly volatile, unconstrained capital expenditure. Uber's management had to institute a hard spending cap for $1,500 per tool per month for all employees just to stop the bleeding. And here's the terrifying part. Uber has a massive $3.4 billion annual R&D spend. They can absorb that shock, but smaller enterprises, they can't afford to survive an unforecasted 4x budget overrun. And as Uber COO noted, this massive token spend does not proportionally map to an increase in shipped revenue generating consumer features, projected at $2 for every $1 of revenue brought in. That VC subsidy cannot last indefinitely once public market scrutiny is applied. But if you're sitting there typing in the comments right now, well, the cost of tokens will just come down, right? Oh no, that's the exact problem. A $1 trillion market valuation can't be sustained on a digital product whose unit economics are plunging towards zero. And Chinese AI labs, operating entirely outside the inflated pricing structure of Western hyperscalers, are actively driving this global cost collapse. DeepSeek utilized highly efficient mixture of expert architecture to activate only 37 billion of its 236 billion parameters per token. They slashed necessary GPU operations per query, and they migrated their Pro model inference onto Huawei's 4th gen Ascend 950 supernodes. DeepSeek is pricing its V3 model input at roughly 14 cents, 1 RMB per million tokens. OpenAI's costs hover around 60 RMB for the exact same thing. DeepSeek has triggered a race to the bottom that threatens the fundamental operating margins of every single Western AI provider. Because while the US tech industry is selling individual overpriced software APIs to sustain a financial bubble, China is building cohesive full-stack industrial ecosystems. Look at Alibaba's announcements in May of 2026. At the silicon level, Alibaba's T-Head subsidiary launched the Zhenwu M890 AI processor, featuring 144 gigabytes of HBM3 memory and 800 gigabytes per second of interchip bandwidth. At the infrastructure level, they integrated these custom chips into the Pangeo AL128 supernode server, linking 128 accelerators in a single rack to handle petabyte per second bandwidth, specifically for agentic concurrent requests. At the software tier, they launched the Qwen 3.7 Max model, natively supporting a million token context window and explicitly optimized around the Junwu architecture. In a public demo, Qwen 3.7 Max ran autonomously for 35 hours without human intervention. It made about 1,158 tool calls, it evaluated 435 kernels, and it successfully optimized Alibaba's own AI chip by a factor of 10. The takeaway is stark, if you believe it. American enterprises are rationing AI use to prevent budget insolvency caused by disjointed, overpriced components. Chinese enterprises are owning the entire stack, from the TSV logic folds in the silicon to the agentic reasoning models, and they are preparing to sell that cohesive ecosystem to the rest of the world very soon. And let's talk about the consumer, because the relentless corporate pursuit of the $40,000 data center AI chip has caused American tech giants to fundamentally abandon you. Nvidia's aggressive pivot towards enterprise AI means consumer GPUs have become prohibitively expensive and artificially scarce. They alienated the global gaming, prosumer, and enthusiast user base that originally financed their rise. On the Korean gray market, global editions of the RTX 5090 climbed to an exorbitant $5,300 due to procurement pressures. In May 2026, Chinese GPU manufacturer Li Xuan Tech launched the LX7G100 Extreme Founders Edition, built on their self-deployed true GPU architecture on the TSMC's 6nm process. It became the first Chinese GPU to earn Microsoft WHLQL driver certification. It costs around $485. It performs on par with the 2021 era RTX 3060, and it struggled to maintain 60 FPS. But dismissing the LX7G100 due to its current performance deficits misses the macroeconomic significance entirely. Li Xuan Tech proved that a domestic Chinese firm can write its own infrastructure set from scratch, build a complete software stack, secure Microsoft driver certifications, and achieve out-of-box compatibility with modern DirectX 12 AAA games without catastrophic system crashes. By offering good enough hardware, they are establishing a vital beachhead. As their silicon yields improve, they will inevitably swoop in and capture the massive global lower to middle tier income consumer base that US tech sector has completely priced out of and abandoned. But let's go even deeper, because this rot goes on for miles. Let's talk about the absolute bedrock of the entire technological revolution, the printed circuit board, the PCB. Without the PCB, there's no AI, no telecommunications, no modern defense apparatuses. Over the last 2 decades, the United States actively outsourced its foundational manufacturing to maximize corporate profit margins and sidestep domestic environmental regulations. Our share of global PCB manufacturing plummeted from over 30% in the late 1990s to a devastatingly low 4% today. Meanwhile, China now controls over 60% of the global PCB market. This creates a severe, unmitigated national security vulnerability. The Department of Defense mandates that defense electronics be sourced domestically under ITAR and DFARS regulations to prevent tampering in missile seekers and radar. Yet with only 4% of global capacity, our domestic supply chain is stretched to the absolute breaking point. Recognizing this impending crisis, the US government panicked. They prolonged legislation with 25% tax credits and $3 billion in grants to incentivize American-made PCBs, tapping domestic heavyweights like TTM Technologies and Samana Corporation. But achieving full US hardware independence, it's a profound myth. Despite facility expansions in places like Ohio and New York, the underlying raw materials and the chemical laminates and the secondary components required to fabricate high-density interconnected boards are still overwhelmingly sourced from Asian supply chains. We cannot suddenly rebuild an ecosystem of chemical refining, substrate weaving, and metallurgical plating that we spent 30 years systematically dismantling. The foundation is fundamentally rotten. Throwing venture capital at AI software models will not fix a hardware supply chain that no longer physically resides in the West. And beyond that, the final nail in the coffin of American technological supremacy is the steady hemorrhaging of our own most valuable assets: human capital. Historically, the US maintained global leadership from an exceptional capture effect. We attracted the highest performing international students, integrated them into the world-class research networks, and retained them to fuel domestic innovation. But we're deliberately dismantling this structural advantage. Over the last decade, political polarization, xenophobia, and the DOJ's China incentive and severe H-1B visa backlogs have created a toxic environment for foreign-born, specifically Chinese-born researchers. Highly publicized cases like the wrongful targeting of MIT professor Gang Chen sent shockwaves of fear through the academic and corporate tech communities. A comprehensive survey of US-based Chinese scientists revealed the deeply psychological toll. 72% expressed feelings of insecurity, 42% feared arbitrary restrictions on their research, 35% reported feeling actively unwelcomed in the United States, and 86% of institutions noted increased difficulty in recruiting international students compared to 5 years ago. The result is quantifiable: catastrophic reverse brain drain. According to Stanford data, the number of Chinese-born scientists leaving the United States surged by a staggering 75% between 2010 and 2021. Crucially, of those who departed in 2021, 67% relocated to mainland China or Hong Kong. That is a massive shift from 48% in 2010. These are not entry-level coders. These are top-tier, globally recognized architects of the modern technological era. Structural biochemist Yang Ning, leaving Princeton, degenerative disease expert Xiaoyang Dongfu, leaving UC San Diego, and prominent biochemist Kun Liang Guan, returning after 30 years inside the United States. I'm sorry if I got your names wrong. I have trouble reading. I'm dyslexic. We spent a decade training the brightest minds in the world on aggressive Western hyperscaling mentality, but because they feel targeted, marginalized, and physically insecure due to hostile federal policies, they are returning to China. And in China, they are welcomed as heroes, showered with state research funding, given the explicit mandate to build alternative technological systems. The US is effectively deporting its own people. We have handed a pool of elite, highly trained talent directly to our primary competitor, and at the exact same moment, China is successfully decoupling its tech stack from Western control. And this is all while the United States is currently in the middle of an AI bubble, and there's nothing we can do. Our tech sector is not failing because China inherently stole our secrets or engaged in asymmetrical warfare. It's failing because of a self-inflicted chest wound because of corporate rot and boneheads being elected into office. And those boneheads attempted to suffocate our primary competitor, but instead, we forced them to permanently cut the umbilical cord and completely remove themselves from Western tech reliance. And I think it's about time we reevaluate those boneheads in office, those boneheads who are currently running the largest companies in the world, and remove them, and replace them with people who are halfway decent and halfway competent. But we all know that will never happen. If you guys want to watch another video from me, I suggest you guys watch the Anthropic video. It's right there. You can click it right now, I think. And yeah, thank you guys for watching.